Hi, so summer is here, obviously and awesomely, and that means we're getting lots of sun and it's really hot. And it means a couple of things to me actually, because the first thing that occurs to me obviously is how to get that sun into some energy so we can use it. And the other thing that I realise is though it's hot, what everybody's going to be doing is turning on their air conditioning and using a ton of energy that perhaps they don't need to use. So those two thoughts tend to be uppermost in my mind during summer. Just like in autumn when it's windy, I think of wind generators. When it's sunny in the summer, I think of solar. Now we did something in a previous video called Simple and Cheap Method for Getting Clean Water. And to do that we used this stuff, which is Oasis. And all we did with the Oasis was put it in a bath and then put some of this stuff, which is carbon felt, over the top of it. Now Oasis is quite stunning stuff actually. It will wick water like you wouldn't believe, and I tried that. So I put that in a thin film of water and it wicked it up that far, which is kind of impressive if you think about it. But I also tried a bit of the carbon and I dipped the bottom in and it wicked it up that far, which is even more impressive. So that's quite a lot of wicking action it has. So we lay it flat like this, as long as it's kind of thinner than that, it's going to pull that water up through the Oasis and into the carbon. And that's exactly what happened here. Now we shone the sun on that and we evaporated the water, and obviously it's basically a solar still. All that water evaporates and is nice and clean, you collect it, you've got drinkable water. And it does it at a rate of knots. But while I was doing that, I kind of noticed something else. And this is one of the things I love about science. It's about noticing. And I put my hand on here. Actually, I was trying to see how wet it was getting. But one thing that struck me was how cold it was. Anyway, I've got a little experimental setup I want to show you. Let's go have a look at that. Okay, so I've had this in the sun. I've moved it here so that you can actually see the reading. And you see it's 16 degrees centigrade. Now, it's only been here for about 40 minutes or so, but the ambient temperature today is 32 degrees centigrade, and if I touch that cloth, you can really feel how much colder it is. So I'm going to put it back in the sun, try and reshoot it if you can see it or not, and then leave it for a while. Okay, we're in the direct sunlight, so I hope you can see that reading. We've been here in total about an hour. And it's 15 degrees centigrade, while the ambient is 32. Amazing. So as you can see, what I did was stick a temperature measure into the foam, stick it in its condition, and then read that coldness on the top. Now I thought it was particularly awesome, and I can hear a lot of people saying in the background, so what? Well, 18-20 degree temperature difference between the surrounding environment and the layer here that was caught in here is very significant indeed. We can use that as an air conditioning unit. So if we pump the air in there, it will come out cold. Now if we were just to drill holes in the foam and blast the air through the foam, we would get cold, wet air. Because basically there are a number of ways of trying to construct an air conditioning unit. Now the commercial air conditioning units are basically the reverse of a fridge. They have a huge thing which is like a radiator that blasts the cold air out. You get a gas being compressed and let released to form a liquid and a gas, so that's called a phase change, and the other side it gets really hot and we can blast the air out. And that's how we make the cold air. There's an awful lot of homemade air conditioning units where essentially what you do is fill a bowl with water and blow the air across the water. You do the same thing with ice. You fill a bowl with ice and blow the air across the ice. Of course it cools the air, and there are quite a number of these units available for sale. They're really cheap and they work okay, and they blast a bit of cold air out as long as the ice or water lasts. But of course it's very humid air that it blasts out, and you keep topping it up. The air conditioning unit have a couple of styles. One is the mobile unit, where you've got all this stuff in one case. It sits in your room and it chucks out heat from the back and cold from the front. So that's not particularly good, obviously, because it's chucking the same stuff out into the same room, and so you're having to recool the air that's been heated by the unit. So what they do is a split system. They take the hot bits and stick it outside, so when you walk past these things hanging on a window or sitting on the roof or sitting in your garden, That is the hot section. And then they run some pipes into the other side, and that's the cold section. And that section looks like a refrigerator panel. Normally that's near your furnace or near a central distribution, and you blow the air over that. That separation makes the thing very, very much more efficient. So those are the kind of ideas that were occurring to me. And what we could do with this is, rather than in the cheap and simple version where you just blow air across, we could do that separation and run some pipes through this Oasis foam and take those pipes into the house. So this thing could sit absolutely wherever you like. It's just somewhere where you can feed it with drip water or maintain it easily. As long as it gets a bit of sun and wind on it, it's going to work just fine. Feed the pipes in and out, and then take those back in to the heat exchange unit, which would be the cold end. So that would give out that cold, warming up, come back here to cool down again. So it occurred to me that this could well be the basis for a very effective air conditioning system where you're not actually using a terrible amount of energy. The energy you're going to be using here is basically from the sun and a small pump to pump that liquid around. That's going to be your energy requirement. Now obviously at the moment, this is a baseline experiment. It looks nothing like an air conditioning unit. What we've got to do really is put this in some kind of case, feed some pipes in and out of here so that we have an in and an out, pop our bit of carbon foam on, and then put that case somewhere that's convenient, attach a pump and see if the damn thing works. But that difference in temperature that we were getting there, like I say, was extraordinarily impressive. Now if you want to build a box where you blow air over ice, knock yourselves out. It's a piece of cake. Just get a box, chuck some ice in, get a PC fan and get an outlet. You will get an air conditioning unit. Problem very often with that, obviously, is blowing water into the air, and that can make it quite humid. The thing about this is it wouldn't be blowing that water into the air, it would just be cooling the air. And if we make it a split system, then we should get actually quite a lot of efficiency out of it. Well, certainly wanted to share that result with you because, you know, people are really quite inventive, I find, and having a baseline result like that I think will help a lot of people start to think about how you actually might make this into an air conditioning unit. Obviously I'm going to go and make this into an air conditioning unit. It's probably the very next step I'm going to do actually, because it's really, really interesting. But I wanted to share the early results so that people could have a think about it too. Anyway, I hope that was of interest to you, and I hope it does catch your imagination. Thank you very much for watching.